Hello, chemists! This is Miss Placino, and you are watching lesson 5.1 on naming ionic compounds. On today's lesson, we are really just going to look at how the formula and the name of ionic compounds are determined. So we're given one, and we have to figure out the other. Naming ionic compounds is kind of involved. My suggestion is to get your reference table. You will definitely want it today, and just be patient. It takes some time to get comfortable with this. Goals for today's lesson. First, we need to recall what ionic bonds are and what sorts of elements will bond ionically. Then we're really just going to focus on naming. We'll look at names and formulas of simple binary ionic compounds. We'll also look at ionic compounds with transition metals and ionic compounds with polyatomic ions. So all about naming. Everything in Unit 5 really requires a lot of practice. Conceptually, this is not a particularly difficult unit, neither is this a difficult topic, but it's going to take a lot of reps, a lot of practice for this to start coming kind of second nature. Let's get into it. All right, we're going to start with binary ionic compounds. What does binary mean? How many things? Yeah, two. So these are going to be ionic compounds that consist just of two different elements. Hopefully you remember from ionic compounds you need a metal and a non-metal to bond with each other. So let's look at one you are definitely familiar with, NaCl. What's the name of that compound? It's not NaCl. It is sodium chloride. I'm sure you knew this one. If you had to kind of explain what's going on with the names, what's happening to the name of the metal? No, nothing at all. Na on the periodic table is sodium, so the metal in ionic compounds keeps its name. What about the nonmetal? Is Cl chloride on the periodic table? No, it's chlorine. So our nonmetal is going to drop its ending and turn it into IDE. So instead of chlorine, we'll call it chloride. You might be wondering, well, how do I know exactly where to chop it off? And just try to say it out loud. If it sounds kind of normal and sciencey, you got it right. If it doesn't, you got it wrong. Chloride, okay. Sulfide, sure. Nitrogide, no. Nitride, it's usually like the last syllable. We do not use prefixes to denote subscripts. Like we wouldn't call this monosodium monochloride because there's one of each, because binary ionic compounds, and all ionic compounds for that matter, have to combine in a fixed ratio based on the charges of the ions. We don't have to explicitly state what the subscripts are. Let's go in the opposite direction. Let's see if we can do this one. Barium bromide. First thing you need to do are find those elements on the periodic table. Barium is a group 2 metal. Bromine is a halogen. So I've got Ba, and then bromide, that must be bromine. Done! Careful, we need to look at charges as well. Barium as an alkaline earth metal will have a +2 charge. Bromine as a halogen will have a -1 charge. They're not going to combine in a 1-to-1 ratio. Remember the crisscross method? We would need 2 bromide ions to balance out the +2 charge of barium. So yeah, BaBr2. We need to find the charge of each ion. Use the crisscross method. We know that the charge of the cation becomes a subscript for the anion and vice versa. And make sure that we reduce the subscripts to lowest terms or simplest ratios. 1 to 2 can't simplify any further. For a lot of students, this is the trickier part. Taking the formula and producing the name, not as difficult in the case of ionic compounds as taking the name and having to get to the formula. A little bit more work to do there. All right, pause the video, try out these practice problems. All right, let's review these. MgF, that is magnesium fluoride. Do not call it magnesium difluoride. Mg is always 2+. Fluorine will always be 1- to make the fluoride ion. It has to be MgF2, so we don't have to say magnesium difluoride. Moving right along, LiBr, lithium bromide. K2O, potassium oxide. SRS, strontium sulfide. All right, now let's go in the other direction. We've got the name. Let's work to the formula. Sodium fluoride, just NaF. That's a +1 and -1 ion. Potassium phosphide. Potassium is +1. Phosphorus would be -3 in the phosphide ion. So that should be K3P. Magnesium oxide, Mg2 plus, O2 minus. Make sure you reduce it down, MgO. And calcium nitride. Calcium would be +2, nitrogen, and the nitride ion would be 3 minus, Ca3N2. All right. Hopefully, you're 8 for 8 on those. Again, it's going to take practice. Let's make things a little bit more complicated. So what we've looked at so far are metals that have only one possible charge. Everything's coming from groups 1 and 2. So they'll always have +1 or +2 charges respectively. If you look at the transition metals and even some of the base metals over in the P block, you're going to see multiple charges. So we've got to specify which one we're looking at. So if we're going to look at something like Mn2O3, this is definitely some sort of oxide. Find Mn on the periodic table. Element 25. Oh, geez. You can have a whole bunch of possible charges. This is a manganese ion. What's manganese's charge in this specific ionic compound? Well, we know that the subscript of the anion is related to the charge of the cation. Oh, so I guess this must have been a manganese 3+ ion. We would call this manganese, parentheses, Roman numerals 3, oxide. That 3 tells us that we're talking about the manganese ion with a charge of +3. So the metal still keeps its name. Remember that the subscript of the anion comes from, sometimes directly, other times you might have a little bit of math to do, from the charge of the cation, and the same rule applies to the nonmetal. Drop the ending, add -ide. Opposite direction. Cobalt-2 fluoride. Let's see. Cobalt, that 2 is telling me the charge, must be 2+. Fluorine is always going to be a -1 ion, a fluoride ion, crisscross method. COF2. Remember that the Roman numeral is just telling you the charge of the cation, and before you reduce it, it will also be the subscript of the anion. No reducing or simplification needed here. You know what's happening next? We're going to try out some practice problems. So again, pause the video, try these out. All of the metals are coming from somewhere in the D block, so hopefully, well, I guess that's not entirely true. There is a base metal in there too. But pause it, try these out, we'll check in a moment. Let's see how you did. CO2S3, that's cobalt-3 sulfide. TiF2, titanium-2 fluoride. NiCl3, nickel-3 chloride. This is one that always gives students trouble. CrO3. Did you put it on autopilot and just decide that this must be chromium-3 oxide? If you did, be careful. We know that oxygen, when it becomes an ion, always has a charge of -2. So if we do the crisscross method, we end up with Cr2O unknown, but we do know that the final formula is CrO3. What's the charge of chromium in CrO3? Yeah, it's not +3, it's actually +6. Make a note to yourself somewhere. Always take a second and double check with like your your -2 anions. So group 16s in particular tend to cause some problems with this. Just kind of making it a little bit more complicated because you often see kind of like a reduction or simplification of the subscripts occurring. All right, copper-2 chloride, CuCl2, platinum-2 sulfide. It's not Pt2S2, it's just PTS, simplify. Iron-3 oxide, Fe3, Fe2O3, and lead-2-bromide. Yeah, lead is not technically a transition metal, but it is able to have multiple charges, PbBr2. Okay. So with your transition metals or your metals that can have multiple charges, you need to go through and tell us what the charge is. Not all transition metals can have multiple charges. For example, if you look at element 47, silver, Ag, it is always a +1 ion. If you look at zinc, technically not a transition metal, but number 30 in the D block, it is always a +2 ion. Some of them don't have multiple charges, so you really only need the parentheses when you see multiple charges listed on the periodic table. All right, ionics with polyatomic ions. What does the word polyatomic mean? The prefix poly means many. Atomic, probably referring to atoms, so many atoms. Oh, so ions that consist of many atoms. Great. Let's say something like this, Na2SO4. Uh-oh. I know what that is. That's sodium. What on earth is that? We only learned how to deal with binary compounds, so I don't know what to do with that. Use your reference table. If you flip open to, I think it's table E, New York State has done you a solid, and they've given you about 20 or so selected polyatomic ions. Can you find SO4 on that table? Spoiler alert, of course you can. It's called sulfate, SO4 2-. So I must call this sodium sulfate. What happened to the name of the metal? Absolutely nothing. What happened to the name of the polyatomic ion? Well, it's exactly the same as it is in the table. And never ever change the name of a polyatomic ion. I know this is weird coming from your chemistry teacher, but spelling matters here. Those endings, specifically, it's the vowel. Ate, it makes a difference. So make sure that you are reading carefully and that you are writing carefully. But never, ever, ever change the name of a polyatomic ion when you're naming an ionic compound. Let's even go in the other direction. Calcium nitrate. All right. I know calcium. If I check the table, calcium, alkaline earth metal will always be +2. Nitrate. Okay, I'm going to use, and since it's ending in 8, that should be kind of a sign that it's a polyatomic ion. Polyatomics, if you look at the table, they tend to end in 8 and ite, especially if you're talking about the anions. So nitrate is NO3, the charge of -1. So when I do the crisscross method, I'm going to come up with CaNO3 2. Oh, well, that looks ridiculous. That looks like calcium, nitrogen, oxygen 32. Oh man, that's not right. Maybe I would do what if I distribute it like I would in math class? N2O6. Technically, we don't do that either. How can I represent it so that I'm conveying the idea that I need 2 nitrates? This is where parentheses come in. You can think about the parentheses as protecting the polyatomic. Here I'm saying I've got calcium, a calcium ion, an ionic bond with 2 nitrate ions. This is what you need to do. You really only need the parentheses if you're going to have multiple polyatomics present. Sorry, there's a mess over that. We're going to treat the polyatomic as a group. So that means do not alter the subscripts. I understand why at this point in the game you might be thinking, well, wait a second, aren't those two like basically the same exact thing? I just distributed through the way I would in math class. Technically, you're right. There's the same number of nitrogen atoms. There's the same number of oxygen atoms. Of course, the same number of calciums. We use this one, calcium, or Ca parentheses NO3 2, because this gives us more information. As a chemist, you'll be able to see NO3 and know, oh, that's nitrate. This might not ring that bell as quickly. So yes, I understand your subscripts are technically correct, but that is not the proper way to write the formula. We need to use the parentheses. So never alter the subscript of a polyatomic. And again, if you need multiple polyatomic ions, which you will from time to time, use parentheses. Don't change the subscripts. Don't do this craziness here where you just kind of like throw an extra subscript on. Time to do some practice. Pause the video, try them out, check your work. Let's take a look at these. First one, SR parentheses CN2. This is strontium cyanide. Cyanide, one of the rare polyatomic ions, anions that ends in IDE. Cations can be polyatomic as well. This is a really common one, NH4 parentheses 2O. That's ammonium oxide. Al2 parentheses SO3 3. Aluminum sulfite. Careful with the spelling. It has to be sulfite, not sulfate. Ag2CO3. That's silver carbonate. Let's go in the other direction. Lithium chromate, Li2CrO4, calcium acetate. If you look at the reference table, you'll see two formulas for acetate. Which one do you choose? Well, if you look carefully, they're conveying the same information. One's what we call a condensed structural formula. The other is just a molecular formula. At this point, they probably mean exactly the same thing to you. It will mean something slightly different later in the school year. I prefer to use this one, but if you wrote the other one, C2H3O2, that is equally correct. Barium hydroxide, BaOH2. Students often forget that 2 for some reason. Make sure you've got the parentheses. And cesium hypochlorite, CsClO. All right. As I said at the beginning of this lesson, it takes a lot of repetition to get good at this. There are practice problems available in your workbook. I would really suggest, even if it's just like 5 to 10 minutes a day for the next couple days, try to get through some more naming practice. It's really easy to make careless mistakes. And my guess is that this is the unit where you really start to quickly find elements on the periodic table. All right, that does it for today. Thanks for tuning in, and I hope you found this helpful.